So in the previous video, we looked at a couple instances where factoring might be useful. Now we need to develop our techniques for factoring. So the first technique is to factor out common factors. So let's consider the expression 2x plus 6. So when we look at this, you will learn to think of this in terms of factors for every term. What I'm writing in pink is what should be going on in your head. So 2 times x is what the first term is, and the second term could be rewritten as 2 times 3. And since both terms have a 2 in common, this could be rewritten as 2 times the quantity x plus 3. Remember, just a few videos back, we saw that if we took 2 times the quantity of x plus 3, we would get 2x plus 6. So when we go in the reverse, so factoring, the thing we just did, is the reverse of what we had done previously. What we had done previously, we would have said expand the expression 2 times the quantity x plus 3, or distribute the 2 to the x plus 3. When we took 2x plus 6 and we converted it into 2 times the quantity x plus 3, we say that we have factored out a 2, but the directions to a problem might be factor 2x plus 6. Let's look at a couple of more examples. So let's take a similar example, 3x plus 6. If you look at that one, once again, you don't have to write what's in pink. You would recognize that you have 3 times x plus 3 times 2. So this time you could factor out a 3, and you would be left with x plus 2 for your second factor. And it's pretty easy to see that if you were to distribute the 3, you would get back to the original expression. So once again, we've done the reverse of expanding. That's what factoring does for us. Now let's take another example. 2x squared plus 6x. And when you look at that, we have several things in common. If you look at the first term, it has a 2 and an x times another x. And the second term has a 2 times an x times an additional 3. So if we wanted to factor it, we could note that 2 times x is inside of both terms. So we could factor out a 2x, and then we could realize that we would have one more factor of x in the first term, and we would have a factor of 3 in the second term that hadn't factored out. So if we redistribute, we would get back to our original expression. So we know that we have correctly factored the expression. Now, a couple of things of note here. Mathematicians, if you have a choice with a monomial times a binomial, you almost always write the monomial first. So you will not see x plus 3 times 2x written. It just gets a little bit confusing when people write things in different ways. So this tends not to ever be written out. Also, let's point out that this, if we had been given the problem 2x squared plus 6x equals 0, this was one of the cases where factoring was useful. If we rewrote it as 2x times x plus 3 equals 0, we would know that 2x must be 0, or x plus 3 would be 0, and making solutions that x must be 0 or x must be negative 3. So we can see that two values would make the original statement true. If we put 0 in here, 2 times 0 plus 6 times 0 would be 0. And if we put negative 3 in here, we'd end up with 2 times 9, which is 18, plus 6 times negative 3 gives us negative 18, and we would get 0 again. Let's look at one final example. Let's consider the example 2x squared plus 6x minus 4. So here we have a trinomial. And so if we look at this, we can see we don't have an x in the last term, so I can't factor out a 2x. But I still have a factor of 2 in every term. So I could factor out a 2, and that would leave 2 factors of x in the first term. And in the second term, it would leave a 3 and an x as factors. And in the last term, it's a negative term, so you have to leave the negative sign there. Factoring out a 2 still leaves a factor of 2. So I factored 2 out of each term, and so what's in parentheses is what's left when I essentially divide a 2 out of each term, but then I turn around and multiply by the 2. So if I were to redistribute, I'd get back to the original expression, but all 3 terms have the 2 in common as a factor, and so we can factor in that manner.